So last time we were working with absolute value equations and how you would come up with the solutions there and then wind up graphing them. Here we're going to be working with absolute value inequalities, and we're going to have to graph these as well. Anytime you have an inequality, generally you have to graph it in order to show the solution, so we can't forget to do that. The rules are pretty much the same. To solve absolute value inequalities, the special rule for multiplying and dividing by a negative still holds. You still have to split into case 1 and case 2, and you also have to graph. From the graph, you might determine that there actually is no solution. So it is possible to come up with no solution in this case. I'm going to show you that. All right, solve and graph. Remember, we have to isolate the absolute value symbol first. All 4 of these are already isolated, but if there was some other stuff attached to the absolute value, we'd have to work through it like we did last time. So we're ready to split into case 1 and case 2. Case 1 and case 2. Remember, case 1 is the positive case. It means we're to the right of 0 on the number line. So case 1 is exactly what you see. 2x minus 1 is less than 5. Case 2 is the negative case. Technically, over here, I'm going to write this off to the side. Technically, what you're going to have for the negative case is negative, parentheses, 2x minus 1 is less than 5. But what we're going to write for case 2 is 2x minus 1, meaning I got rid of that negative that's attached. How did I do that? I divided by a negative, or I multiplied both sides by a negative, right? Well, if I do that, then I get negative 5 on this side. But remember the special rule for multiplying and dividing by negatives? When I do that, I have to do what? I have to flip the symbol. So it was less than, it's now greater than. So basically, if you understand this and why that symbol has to flip, you can ignore doing this and go case 1 is the positive case. Case 2, the absolute value thing stays the same. Flip the symbol, change the sign on the right. I'll be okay with that. So let me get rid of what we wrote over here. And let's continue. Okay, we have case 1 and case 2 now, so we're just going to solve. Add 1 to both sides. 2x is less than 6. Divide both sides by 2. And x is less than 3. For case 2, we have add 1, 2x is greater than negative 4, divide both sides by 2, and you get x is greater than negative 2. We divided by a positive, so there is no sign flipping here. It doesn't matter that this number is negative. We divided by a positive 2, so the symbol stays. All right, now we have to graph, and I don't have a whole lot of room up here, so I'm just going to go down here. I need to have negative 2, and I need to have positive 3. X is less than 3 tells me open circle, and less than is that way. X is greater than negative 2 tells me open circle, and greater than is that way. And what kind of graph does it look like we have here? It kind of looks like an and. If you look back at the original inequality, this says whatever I do with the absolute value has to be less than 5 units away from what? Remember last time we talked about what absolute value means? Absolute value is a distance from 0. So this absolute value right here has to be less than 5 units away from 0. If I draw that idea, this is not the answer, I'm just drawing that idea. Here's 0. 5 units away to the right would be positive 5. 5 units away to the left would be negative 5. And my answers have to be less than 5 units away from 0. That's what that says right there before I solve it, right? So less than 5 units away from 0 means I could be anywhere in here. Anywhere outside of there, I can't be. So that's going to be an open circle there, an open circle there, and I would be shading in between. What kind of statement does that look like? and. Did I get something that looks like an and statement? Yes. This actually connects here, and that's my graph. Go ahead and try the second one, same way. So, case 1, case 2, right? Okay. What's case 1? Less than or equal to 8. Case 2? Greater than or equal to negative 8. Make sure you flip the symbol and change the sign. All right, so now we solve, and we can do that probably pretty easily. Plus 4, 3x is less than or equal to 12. Divide both sides by 3. And x is less than or equal to 4. Over here, add 4. And I get 3x is greater than or equal to negative 4. Divide both sides by 3. And I get x is greater than or equal to negative 4/3. Can't reduce that. So now we graph. We need those two answers on our number line. Negative 4/3 on the left and positive 4 on the right. That's good enough. Greater than or equal to for negative 4/3 tells me solid dot up in this way. Less than or equal to for 4 tells me solid dot up in this way. Is this supposed to be an and statement? Is it supposed to look like that? Yeah. Because up here it says we're supposed to be less than 8 units away from 0 when we first started this problem. So that's going to be an and statement. We're closer than 8 units in. It's like this graph right here, which is and. So we're going to connect these two, and we're good. If this problem was written like this and you wound up with a graph that did not look like an and statement, that would be no solution. Okay? All right, I don't have a whole lot of room here, so let me erase some stuff. For this third one here, 2x plus 4 in the absolute value is greater than or equal to 6. We can probably come up with case 1 and case 2 right now. What do we get for case 1? Okay, case 2? Good, flip the symbol, change the sign. And then just like before, we're going to solve. So we subtract 4 from both sides. We have 2x is greater than or equal to 2. Divide both sides by 2, and I get x is greater than or equal to 1 for that first one. For the second one, subtract 4 from both sides, and we have 2x is less than or equal to negative 10. Divide both sides by 2, and you get x is less than or equal to negative 5 for the second one. Need to draw a number line here. I have 1 and negative 5, so I'll put negative 5 on the left, 1 on the right. X is less than or equal to negative 5 tells me solid dot, up and less than. X is greater than or equal to negative 1, solid dot, up and the other way. What kind of statement does this look like? This one looks like an or statement. Let's go back to the original problem and think about this for a second. And I'm going to put this over to the right side. If I have the absolute value of something, meaning the distance from 0 of this thing has to be farther away, greater than or equal to, farther away than 6. If I draw my number line from my original problem, here's 0. 6 units away to the right would be 6. 6 units away to the left would be negative 6. But I'm supposed to be farther away than 6. So that's not the stuff in between. I can be exactly 6. Farther away than that would be to the left. On the other side of 0, I can be exactly 6. Farther away than 6 units from 0 would be that way. Does that look like an or statement? Yeah. So did our graph match what we were expecting? Based on what our original problem was, the graph matches. This is not no solution. This is the solution here. This is an or statement.
So what would it say? Like that?
This is the graph. That's your solution. Yeah. That's what it's supposed to look like. Because of the fact that we have this symbol here. There you go. You're already answering the question I have down at the bottom. What do the graphs look like and in or statements, right? So you probably want to write that down. What can we say about inequalities involved when we're dealing with absolute value? You definitely want to have this written down. If you have the symbols less than or equal to, you are working with and. If you have the symbols greater than or equal to, you are working with or. So your graphs should wind up looking like that. That doesn't mean make your graph look like an and statement or an or statement. It means solve the problem and then look to see that you did it right. If you get an and statement that looks like this, it could be just that you did something wrong. Maybe you forgot to flip your symbol. Go back and try to look for that. But if in fact you got this and your problem is correct, then the answer would be no solution.